Hi there, welcome to my channel. In this video, I'm going to discuss about the solution to check whether a given Sudoku board is valid or not. Let's look at the problem description. We are given a 9 by 9 Sudoku board and we have to check whether it is a valid or not. And we have to validate only the filled cells as per the following rules. So each row must contain the digits 1 to 9 without repetition. And same way each column must contain the digits 1 to 9 without repetition. And each of the 3 by 3 sub boxes of the grid must contain the digits 1 to 9 without repetition. The Sudoku board could be valid but is not necessarily solvable. The partially filled board. And only the filled cell needs to be validated. The numbers present in this column is not repeating. The numbers present in this column is not repeating. This row is not repeating. So like that, each number is unique in that each row and each column and within that grid. So that's why the output is true. And the constraints are the board length is 9 and the column length is 9 and each cell will have a digit 1 to 9 and then the dot. The dot is indicating unfilled cell. Let's look at the approach to solve this problem. So we are given this partially filled Sudoku board and we have to check whether the partially filled cells are valid as per the three rules given. So basically we have to traverse each cell in this board. Okay, so for each cell it has a row index and the column index. So in order to verify all the rest of the elements in the column where that number is present, we have to traverse all the rows with only the current numbers column index so that we can check all these numbers. Same way we can traverse all the columns which are sharing the same row index so that we can check all these columns whether they have the current number or not. Okay, so this is for the second rule. The third rule is we have to verify for a given cell we have to check the 3 by 3 grid which do not have the duplicate number. So for that, for any given cell we have to compute the top left corner cell's index. Okay, and from there we traverse 3 rows and 3 columns and check whether that 9 cells do not have the current number. So once all these conditions are true, then we can declare the current number is in a valid position in the board. Likewise, we have to check all the numbers present in the board. Let's look at the flow chart. Input for this is valid Sudoku procedure is the board, which is 9 by 9 size. And first we initialize the variable valid to true. And then we traverse all the cells. Basically this is outer traverse all the rows. And this is an inner loop which traverses all the columns in a given row. Okay, so inside that nested loop we check whether the current cell has a number. If it is not a number, then we don't have to validate, we just skip. If it is a number, we'll have to make a call to isNumberPositionValid function with the board as the input parameter and the current cell's row index, current cell's column index and the current cell's value, and we assign that return value to the valid variable. If the cell is not valid, then we can break out of that inner loop, and the outer loop also break out because we check both the conditions, whether we are visiting all the rows and the valid is true. Okay, so the outer loop also will break. If all the cells, all the numbers are in a valid positions, finally we have the valid contains true. Otherwise, the valid will contains false. Next, we look at the flowchart for the isNumber position valid function. The input for this procedure is the board and the current numbers row index and the current numbers column index and the current number. Okay. First we initialize the valid variable to true. Next we check whether the current number is present in one of the columns in the row at row index. If that number is present, then we have to set the valid to false. Same way we check whether the current number is present in one of the rows in the column at column index. If there is a duplicate, then we set the valid to false. Next we check in the grid 3 by 3 grid where the current number is present for duplicate value. If there is a duplicate number, then we set the valid to false. Otherwise, finally we have the valid to true. If any duplicates present, one of these conditions we set that valid to false. So we return the valid variable as the output. Let's move on to coding. First I initialize the valid variable to true. You have to return that valid variable at the end. And I write the nested for loop to traverse the cells in the board. Then I check whether the current cell is filled by checking the cell's value is not equal to dot. If it is filled, then I check whether that number's position is valid by calling isNumber position valid function that takes board and the current row index and the current cell index and the number present in the current cell. If that function returns false, then we can declare the board as invalid. So I update the valid variable to false and then I break out of the loop. And also I'm including the condition in the outer loop by checking the valid always true. If it is false, break out of the outer loop as well. So then finally return the valid variable. Next I'm going to implement the isNumber position valid function. This function checks all the three rules listed in the problem description is followed or not. First it checks all the cells whose column index is equal to the current number's column index, so that it covers all the vertical cells above and below the current number. If there is a duplicate, then immediately I return false. Next I check all the cells whose row index is equal to the current number's row index. So this will cover the horizontal cells. If there is any duplicates, then I return false. Here I skip the cell whose column index is equal to the current number's column index. Next I check the 3 by 3 grid in which the current number is present. First I compute the row index and column index of the top left corner cell in that 3 by 3 grid. So I compute the grid first row by subtracting the row modulo 3 from the row index. Then the grid column first is computed by subtracting the column modulo 3 from the column index. Then I traverse the 9 cells in that 3 by 3 grid by starting from that top left corner cell, 3 rows and 3 columns. Here I skip the row that is equal to the current numbers row index and the column which is equal to the current numbers column index. And then I check whether the cell has the current number. If so, I return false. Otherwise, at the end, I return true. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool. This program is accepted. Next, I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. The expected output is true. So there are totally 81 cells. So it's hard to do the code walkthrough for all the 81 cells. So what I'm going to do is I will pick up the cell which is not filled, that has the dot, and the cell which has the number. First cell, it is present at the row 0 and the column 2. So in order to validate, first we call this function first. So the valid variable is initialized to true, and we traverse the cells in the board. So in the outer loop iteration 0 and the inner loop iteration 2, we see that cell. First we check whether the cell contains a number. So in this case it has dots, so we do not make a call to the isNumber position valid function, and we simply return and proceed to the next cell. Okay, so that's why the when we entering and exiting, the valid variable is still true. So the next cell is present at the row 1 and the column 4. Okay, so in this case the cell has a digit, so we go ahead and make a call to the isNumber position valid function, and so when the function is called, the frame 1 is created, and in the frame 1 we have the row and column and the current num. The row is equal to 1 and the column is 4 and the current number is 9. So in the first for loop we check all the rows which share the current column. So basically we are checking the value in the column in which the current number 9 is present. So we check, is there any duplicates? In this case there is no duplicates, so we break out of the loop after traversing all these 9 elements. In the second for loop we traverse all the columns in the row in which the number 9 is present. There are no duplicates, so we break out of the loop after processing all the 9 elements. Then we have to check the 3 by 3 grid where the current number is present. So in order to process this, first we have to find the index of the top left corner cell in that 3 by 3 grid. So for that we compute the grid row first and the grid column first variable. So row minus row modulo 3 will give the top left corner's row index value. Same way, the column minus column modulo 3 will give the top left corner cell's column index for that grid. Okay, so in this case the row is 1, column is 4. So 1 minus 1 modulo 3 is 0. So we get the 0th row, and 4 minus 4 modulo 3 is 3. 0, 1, 2, 3. So the column is 3. So 0, 3 is the top left cell's position. So from here we traverse 3 elements, 3 rows and 3 columns, and then check whether in that 9 cells the current number is present. So in this case there is no duplicate, so we go ahead and return true. So that's why when we leave that iteration, the valid is still true. So like this, we have to traverse all these cells in the grid and return the valid. So in this case all the three rules are met for all the filled cells. That's why we get the output true. Next I'm going to do the time and space complexity analysis for this solution. The time complexity for this solution is order of n cube, where n is the number of rows or columns. So in this function the main operation is this comparison. Okay. So in order to determine the time complexity, we need to find how many times this comparison is done in terms of the input size. Okay. For example, the 9 by 9 Sudoku board, we have to traverse all the cells, which is 9 times 9, 81. And the number of comparisons for each cell is done in this function. So this for loop performs 9 comparison, this performs 9, and this nested for loop performs 9 comparison. So 27 times the comparison is done for each function call. So 81 times 21, 2187. Number of comparison is done in order to determine whether the 9 by 9 Sudoku board is valid or not. So if the size is n, then it will be 3 times n. This is basically the comparisons done in the function is number position valid, and this is the number of cells in the given Sudoku board. So totally 3 times n to the power 3. This is 3 times n cube. So we remove the constant factor out of this. So the time complexity is order of n cube. Space complexity is order of 1 because we are not allocating any additional space in order to determine the validity of the board. So the space complexity is order of 1. Thanks for watching this video. Have a great day.